The ability to do work, energy. Energy is what powers movement and change in everything around us. Imagine you're trying to push a heavy shopping cart up a steep hill at the grocery store. Just like you need strength and effort to move the cart against gravity, energy in science is the capability required to perform tasks or cause change. The effort you put into pushing the cart is akin to energy, as both are necessary to overcome resistance and accomplish work, whether it's moving a cart or powering a machine. The energy of a moving object, kinetic energy. Kinetic energy is the energy an object has because of its motion. Imagine you're trying to push a heavy shopping cart that's already in motion. Just like how the moving cart requires less effort to keep rolling than to start from rest, an object in motion possesses kinetic energy, which is the energy due to its movement. In this analogy, the initial push you give to the cart represents the force needed to overcome inertia, while the cart's continued motion is akin to the kinetic energy that keeps an object moving once it has already started. The energy of an object due to its height above Earth's surface. Gravitational potential energy. Gravitational potential energy is the energy stored in an object because it is elevated above the ground. Imagine trying to carry a heavy grocery bag up a flight of stairs. Just like how lifting the bag requires effort and energy due to its weight and the height you're lifting it to, gravitational potential energy is the energy an object possesses because of its position above the ground. In both cases, the higher you lift the bag or the object, the more energy is stored. The bag represents the object, the stairs represent the height, and your effort mirrors the concept of gravitational potential energy that increases with elevation. The transfer of heat energy between two objects through direct contact. Conduction is when heat moves from one object to another by touching them together. Imagine you're trying to pass a secret note to a friend across the table without anyone noticing. Just like the note needs to be physically handed over to your friend for them to read it, heat energy transfers from one object to another through direct contact in conduction. In this analogy, your hands touching the note represent the objects in contact, and the secret message being passed from one person to another is like the heat energy moving from the warmer object to the cooler one. The transfer of heat energy from a warmer area to a cooler area in a liquid or gas. Convection. Convection is the process where warm air or liquid rises and cooler air or liquid sinks, creating a cycle. Imagine you're at a party and the room gets crowded, so you move to a less crowded area to feel more comfortable. This is similar to how heat energy moves in liquids or gases, where it travels from a warmer, crowded area to a cooler, less crowded area. Just like you seek out space to feel more at ease, heat energy seeks cooler areas to balance out temperature differences, creating a flow that we call convection. The transfer of energy by electromagnetic waves, it does not require matter. Radiation is energy, traveling through space as waves or particles. Imagine you're trying to get someone's attention across a crowded room without being able to physically approach them. Just like you might wave your hands or use a flashlight to signal your presence from a distance, radiation transfers energy through electromagnetic waves without needing a medium like air or solid objects. In both cases, whether it's your signal reaching the other person or energy moving through electromagnetic waves, there's no need for direct contact or a physical intermediary. It's all about transmitting a message or energy across space.